Hi, good morning and good afternoon to those of you to the east of us. We are happy to have you on this webinar. This is a business case for BACnet IP. We have with us Phil Zito from Building Automation Monthly. Welcome, Phil.
Hi, thanks for having me.
So between the two of us, we'll go through the business case for BACnet IP, why you want to go there, what the market triggers are for going there, and some pros and cons of both IP and MSCP and what happens going in both directions. A little bit about both of us. I'm the Director of Business Development here at Optigo Networks. I have quite a bit of experience being both in the field, and I worked at a large BMS manufacturer for quite a long time. So a lot of these topics have been talked about for many, many years, and I'm sure we can provide pretty good insight to what's out there and what's happening. Phil, a little bit about yourself.
Yep, so I am the owner of Building Automation Monthly, and we provide online training to building automation professionals, both technicians and salespeople. Prior to that, I was running the technical integration program at Johnson Controls, building all sorts of smart buildings. I built BACnet stacks. I've been in the field, been in sales, been in operations. So I have a pretty wide background as far as the different aspects of building automation.
Great. So I'm sure you've seen all the stuff before with all of its pros and cons.
Yeah, and I keep taking a sip of coffee when I think I can sneak it in. I keep getting caught. I will say one thing starting off before we even kick off is this is a hot topic right now, and I would encourage folks to ask questions as we move along because there's a high likelihood that we might use a term that folks haven't heard before. And rather than doing what I do, where I try to pretend I know what's being said, just let us know if something doesn't make sense.
Great point. Absolutely. Yeah, feel free to chime in.
Awesome.
So going through the business case of BACnet IP, and there's a lot of different reasons to do this. There's a lot of driving factors, but basically everyone talks about the Internet of Things. It's a major term out there in the industry. I'll start by saying a few things about it. The Internet of Things really being driven from the consumer side, which is interesting, but what it really does is drive the technology adoption over into the commercial buildings and commercial space size. People go, well, I see that nice display on your iPhone or one of those type of devices. I want it on my wall in my office. Why can't I have that? And ultimately, it's just not that simple. I wish it was. But the Internet of Things has a multitude of different technology and different devices, and it's got a lot of technology packed behind it that can be applied to a commercial setting. But there's obviously challenges with that. Any comments on that, Phil?
Yeah, it's interesting because it always in the past used to be the commercial sector that drove the residential sector. And now we're seeing the residential sector driving the commercial sector. And we're seeing, whereas on the smart home side, you have a lot of open frameworks with the Smart Things framework, with the Apple framework, with the Amazon framework. But on the building automation side, we still are in the Stone Ages, mainly because of how we go about planning and speccing work. And in order, as you mentioned, to have that smart building, there's certain structures that need to go in place. And that's probably one of the biggest benefits of BACnet IP, as we'll discuss in just a second.
Yeah, and a few comments on the IoT things is right now, even from the home programming, it's based on triggers, right? Mm-hmm. Things like IFTTT, if this, then that protocol. Things like, if this happens, go do this. Well, that's not quite enough in our commercial buildings. We need a lot more information, and we need a lot more higher level functions in order to program it and make it do what we really want. So that's definitely missing.
Yeah, especially if you want to go beyond HVAC, which
absolutely
is what I think most folks envision when they say smart building. HVAC is a subset of the building technologies that folks are focusing on.
Right. And it's, to be fair, it's where the bulk of the controls programming is. right? There's very little programming in the other disciplines. I mean, cameras, you plug it in, it works, right?
Yeah.
So that being said, scalability and flexibility, I mean, why BACnet IP? Why would it handle this better than anything else?
Well, I think for one, the IP protocol is closer to a networking protocol. I mean, it is a networking protocol, but it's closer to the higher stack protocols, HTTP, whereas most of our RESTful APIs sit at layer 7 HTTP. It's a lot easier when you have something that's in your IP stack, both from a development perspective as well as from a technical support perspective, to deal with that versus, and I know I'm going super techie geek here, but versus a data link protocol, which is MSTP. It's purely a physical signaling protocol versus IP. And Ryan, I don't know if you want to unpack all that tech speak I just threw out in the past 30 seconds, because I may have lost some folks, but it's an important difference between IP and the physical layer of MSTP.
It is. I look at the tools you have with IP. It's been around for a lot of years. It's how the internet's run. There's a lot of knowledge around it. There's a lot of tools around it. There's a lot of different things. There's obviously we know how to scale it. We know how to make it flexible. When you bring it down to a 2-wire network or one of these proprietary networks that we've been using, MSTP, for example, your zone level type of network, they were catered to that only, and it doesn't and can't scale. It's got a certain function and a certain life and a certain amount of things it can do in terms of speed and connectivity. So it's simply not scalable.
Yeah. And just a light bulb just went off in my head as well. When you think about the consumption of data from a BACnet MSTP network, it has to be consumed by a supervisory device, which then normalizes that data and ultimately ends up sharing it across most likely an IP protocol in order for you to interface with other systems and do a quote, quote, smart building. Versus with IP, you're already in that IP domain. So the interoperability of devices, it's much easier to do versus having to have that protocol conversion.
Right. So I don't have another stop. I don't have another time delay. I don't have another possible failure. I don't have another choke point.
Mm-hmm. Yeah, it's why I think you and I have talked about this in detail, just offline. I don't think we covered it in a webinar before, but the future of supervisory devices, because those essentially, a lot of folks forget that before JACEs and NEs and PXs, whatever brand you're using, before supervisory devices were these kind of gateways into the BAS, they were simply protocol gateways. That was their main purpose, was to take data from serial networks and convert it in such a way that it could be consumed by user interfaces and such. Now we're looking at those things. What is the purpose of them now that we have an IP network, and what does that have as far as infrastructure for the future of building automation systems?
It's interesting. Maybe it turns there's a lot of different protocols that sit under IP, right? Now we're talking about BACnet over IP or various things. Maybe a co-op infrastructure, which is a constrained device application. But all of these are under the IP backbone. So it's interesting to see that maybe those protocol converters don't go away, but they change. Instead of changing the medium, they change the data.
Interesting. So like data normalization devices that have data adapter patterns that convert, because that has always been the biggest challenge as someone who did a lot of integration. The biggest challenge was always data normalization to achieve the use case. So, and that still is in a large part the biggest challenge with smart buildings, because data is not something that is specified. It's not something that you look in the specification and it talks about how do you normalize these different forms of data.
No, and everybody assumes that it goes to BACnet of some form. And It's great that BACnet's there for us to be able to bring all these protocols to, and it's becoming the normalization protocol for sure.
For HVAC and for some lighting systems, I would agree. If you look at AV, so you mentioned early on about BAS as a highly designed, programmed system. I would argue AV is probably the next parallel to BAS as far as needing to be programmed, scenes, and use cases. And a lot of that is actual pure line code, pure programming code. So it's interesting. Something I've talked about in the past is when we bring all these smart buildings together and we're bringing the data in, what system is going to be the consumer? And I would almost argue that maybe another system other than BAS is going to be the primary consumer and visualization platform for data. But still, even with that, how do you consume stuff into these other systems like an AV system if it's MSTP?
That is a concern. You're going to move it up from one protocol into another, and depending on how often you want that data, now you're putting a strain on that conversion. And it's definitely an interesting topic. I would agree with you that BACnet may not be the only spot. There's going to be something else out there. Now, whether it's all brought together in a visualization engine or some other protocol on top, that could be interesting. Either way, bringing everything to some BACnet system, or at least bringing some sort of network up to IP, definitely opens the door for some future proofing.
Yeah. Now, I know whenever, and I'm sure you've experienced this, whenever I've brought this up to field folks, especially some of the more seasoned field folks, they're going to argue that IP costs more. And I think we have a slide in this about the different architectures of IP. But I mean, before we leave the bullets of infrastructure for the future and financial savings, I think folks really, if you're not familiar with IP, really have to understand that there are different architectures to an IP system. It's not all the star pattern, which is end runs from a switch to a device. And I think that's really important because I know personally when I first started working with IP, that's what I visualized. And I just visualized expensive, IT grade switches. And I don't think that is the case anymore.
Yeah, that's very true. There's you're talking in terms of infrastructure. It doesn't need to be as enterprise grade as it used to be.
Yeah, and I think that holds a lot of folks back from engaging because they think that they have to go do this, CCIE level network design with the IT group in order to implement an IP system.
Oh, absolutely. But conversely, it's not as low grade as buying some cheap $10 switches and throwing it in your building to make it work. There's definitely a balance in between.
So Linksys switches from Fry's are probably a bad idea.
Well, in some cases, although the switches may work, the deployment of the switch is, if I'm going to go in, I'm going to, connect a switch on to a switch to a switch to a switch all the way down the line. And yes, I have my connectivity, but that's not an infrastructure for the future. That's nothing that you can hang other devices on. Say I want to hang my camera on there, it's not going to work.
Well, and I think that's the biggest, as a technical professional, that's the biggest mental shift that has to happen is we're shifting from needing a dozen IP addresses for our supervisory devices and our server to needing /24/23 subnets with hundreds of devices. And now we're talking about having to, and it's funny because the next bullet is ease of use and staff expertise. And I'm talking about something that for folks with no IT knowledge may seem very scary, but it's actually quite easy to learn. But you're dealing with bigger network domains and you can't apply that same, I'm going to put a switch in the panel and call it a day logic that we do to an enterprise level IP system. What are your thoughts on that?
No, it definitely doesn't work. We need to think more about it. When you come into /23/24, the amount of IP addresses that I need to design my system for. I need to look at the future. We all need to look at the future. Otherwise, I come into a spot where I go, whoops, I ran out. Now what do we do?
Yeah.
And you definitely need that structure, and you need to look at it a little bit closer.
Yeah, I know. Oh, go ahead. You're going to say something.
All right, lost it.
That's all good. I've drank 3 cups of coffee while we were waiting for the webinar to start, so I'm like, ah! All right. So one of the things you and I talked about before the call was that one of our students was challenged by an IT department. Hey, you've got a DHCP pool. Why do you need static IP addresses? Why do you need so many IP addresses? And speak for a second about just the mindset shift. And something I want folks to really take out of this bullet selfishly is the need to understand IP, but also that it's not as scary, because I feel like if we go through the rest of the webinar without addressing that learning IT is not as scary as it sounds, that we may have some folks tune out.
Yeah, that's a good point. I mean, at the end of the day, IT isn't that scary, right? You've got to, that you need your devices to have an IP address. You know that you need to be able to set them up and have a certain range of IP addresses for them to talk. You know they need to be static. If they're not static, they're harder to talk to, or you can't talk to. But these are all good things, because these breed a new functionality. These breed things like I can log into the device directly and I can do commissioning. I can do location-based tracking. I can do I could do commissioning. It enables so much more functionality than you could never get before. So when you look at ease of use or financial savings or any of those topics, you really have gained more by running an IP topology. And IT is just another method of connectivity. And you take an old MSTP device or something like that, and you teach someone brand new about it. Well, they didn't know anything about it then either. They didn't know that there's a maximum amount of devices. They didn't know that you can't overload it with data because it won't work. They didn't know that you have to keep polarity, or you have to make sure your connections are clean. It's just another set of learning and tools that we need to employ.
Hey,
so let's talk a little bit about BACnet IP versus MSTP, right? How are they different?
Well, I mean, one of them is not a physical signaling protocol, and the other is a physical signaling protocol. And what I mean by that is MSTP, if you've ever had reversed polarity or a line break or stuff like that, you know how damaging that is. With IP, on the flip side, you've seen fragmented packets and networking. The actual software side of IP becomes much more important. Proper subnets, proper IP addresses. If you've got your MSTP device at the right baud rate and you've got it on wired up right, it's going to communicate. But on the flip side, as we've seen, it's very easy to mess up either through signal interference. So with MSTP, there's much heavier emphasis on the physical, and on IP, there's much heavier emphasis on the logical, if that makes sense.
Right. So as the wire rate's less forgiving, there's a lot of better ways to test it, a lot of better ways of, there's better shielding in it. There's a lot of your connections typically don't fail as often.
Yeah. Well, and with IP, you just think about if you log into a switch and you do switch port status, right? And you take a look at the switch port status, just the logical nature of IP, it can help you troubleshoot what is wrong with that switch port just by looking at the switch port status. Whereas with MSTP, you have to get out a scope, you have to get out a multimeter, you have to go chase wires through the ceiling, try to figure out who bumped the end of line on one of the controllers and shut down the entire trunk.
Or did they put it back in when they added another one?
Yeah, exactly. Your T-tapping and fun stuff like that. So, I mean, that's my 2 cents on it. And IP, personally, I embrace IT groups And I like dealing with them because to me, having them manage IP devices when they're properly trained is less of something I have to do, which is a paradigm shift.
It is. It is. There's a lot of yeah, but your training changes too, right? The more that you can get off the pure IP protocol itself, then you can get back into more of the application, the integration, pulling all the stuff together, right? Kind of move it to a high level discussion rather than still being stuck at the physical wiring.
Yeah. And I think there's a lot of, I know there's a lot of folks out there who have never written an actual BACnet stack in Java or in C# or C++, depending on what you code it in. And actually writing BACnet stacks, having done that, you start to see the level of complexity with MSTP, with having to go and deal with masters and slaves and having to deal with MAC addresses versus with IP. Now, one of the pushbacks folks will give on IP is the whole BBMD thing. What are your thoughts on that? Because I don't think it's that big of a challenge when you properly understand it, but
I think that's the biggest piece is a lot of people don't get what a BBMD is. And a lot of people, when they go in and kind of do their own system on their own job, they think I go to a BBMD, go from one building to the next. Okay, that's just the way I do it. They don't necessarily know why, right? To reduce the broadcast so that the internet still works. Yeah. That's basically the reasoning. But a lot of it is people always think that, well, on every system I have, whether vendor A, vendor B, vendor C, I need to have these BBMDs. The problem you have is coordination of them. You don't need to triplicate or quadruple them. You just need one single BBMD. So it opens up a coordination effort. However, the BBMD itself works very, very well. It works. It takes data from here, moves it over there. It's pretty simple. And when you understand it in terms of an IP system and how you do broadcast management, which honestly you should do in your control system anyways, then it starts to make sense, right? Yep. You don't want to send your alarms to everyone, send it to the people that need to have it. No different with IP broadcasting. Same principle, idea.
So that brings up a good point of just broadcast, multicast, unicast. You know, unicast is a one-to-one message. Multicast is a single message to multiple sources. And then a broadcast is to everyone. And something you brought up that's really important for folks to understand, as you said, the BBMD is not the end-all be-all. It's actually the BDT, the broadcast it slipped my mind here. Broadcast distribution table, if I remember correctly. That's something you can Google. So I don't memorize what I can Google. But the BDT, I think that's what you're referencing because you have some manufacturers who their BDTs auto update. You have others that you have to manually update. And that's when I've seen multi-vendors on a site, that's where I've seen a lot of conflict is someone's BDT has to be manually updated so it can't forward broadcasts to new systems.
Right, exactly.
But that's just poor system integration expertise and management. That's, you know, if you're going to be a system integrator, you need to know those kind of things.
Right, and we're not saying we're getting away BBMDs. I mean, whether you do BACnet MSTP or move up into BACnet IP, the problem is the same. Right. Even in MSTP systems, you still need to understand this level of broadcasting and how it affects your IP networks.
Absolutely, yeah, because MSTP is a broadcast as well. It's going to send its signals up and to go to other systems. It's going to do that. So what else?
We talk about some of the topologies under IP.
True. So what are your thoughts?
Well, there's a lot of ways to do a topology in IP. There's some benefit systems differently. You can use these topologies together, sometimes separate. Things like a star topology, these things can make sense depending if you're sending your network out, going per building or per location. But it's definitely important to understand the impact of these what the impact of the labor of the installation is and where the management of it can be.
So talk me through the star. Where's the switch? Where are the devices? What's going on here? What does this mean to a BAS person?
The BAS, think of the star. The star, you're the star of the show. You're at the center. So wherever your BMS is located, it's typically right at the center.
Hmm.
Right?
So, okay. And
So
then
there, then you're running out to your switches somewhere on the floors, right?
okay.
Whether it's a closet or hopefully you get an IT closet. Well, that's where it's branching out. But the difference here is it's a home run.
Yep.
Right. So starting one location and running out as many wires as you need to connect these locations.
Okay. So this would probably be the most expensive topology.
I would say so, and especially on labor, absolutely.
Okay.
What are your thoughts on that?
I think it can be the most expensive on material and labor. I think depending on reliability. So there's always pros and cons, right? So if you are in a tier 4 data center and you're doing an IP architecture and you have a star topology and you want to have each link be individual, then in that case, the cost of this may override the ability to troubleshoot link failures. So there's pros and cons. Of course, in all of these topologies, the switch will be the single failure point. Right. Depending on if you've implemented redundancy. Now, folks will push back and say, well, if the switch fails, I lose network. Well, if the supervisory device fails, you lose network. So, I mean, it's kind of a red herring of an argument.
Well, it's understanding the failure, right? And this goes back to both any type of network, BACnet IP or MSTP. It's when you look at your jobs, you're going, if it fails here, do I care? Does it make a difference? And a lot of times in an IP topology, depending how you implement it, you can actually have an answer for that. You can say, if this fails and I lose, if I lose the air handler and the rest of the zones, is that a big deal? What is it connected to? So it really ties back into how reliable do you want your system and what are you putting on that system to have it fail gracefully.
Yep. And something I don't hear a lot of folks talk about is the concept of blended systems. So doing a star topology to an air handler and then having an MSTP off of that air handler for the zone controllers. That's something I don't think folks talk about enough. Having a star topology to all, like, let's say you have 30 air handlers and a central plant. You run a star topology, and then if you're going to do a zone averaging schema, maybe you have wireless or you have MSTP to the zones. That is one methodology. That is a blended methodology.
Right. And you can carry that forward. And this goes back into our supervisory protocol. You could bring a string of IP devices in a daisy chain format south of that air handler to all the VAVs, and the air handler still does a lot of the translation.
Exactly.
Right? It can hold the graphics, hold the core programming, right, and all that sort of thing. So I think in the applications, nothing really changes. It just gives you IP will give you a few more things.
Yep. Yeah, I wasn't going to bring up the ring or the tree because those are kind of our next ones.
Well, here we are.
But look at that. It's almost like you knew what was going to be said. It's amazing.
Yeah, the tree itself. So if you think about an unmanaged, let's go back to the unmanaged switches for a little bit. I'm going to take an unmanaged switch, and a tree is the most common way that people deploy these, simply because you're not really sure of what plugs into what. So I'm going to plug in my first switch, then I'm going to plug in another switch, or I'm going to home run a few more other switches. And this thing starts to become a very, very unwieldy beast of, I'm not sure where any of my wiring's going. Yes. When we bring that back to failure, you could fail at any part of the network and you really don't know what it impacts. No idea.
Yeah. And this reminds me of LAN FT10. So You know, if you've ever seen a lawn field trunk implementation, it's, you know, it's basically like they took my 7-year-old and let her just scribble on a piece of paper for a while and then, oh, here's the network layout. We're just going to put stuff all over the place. Because that's one of the things is it's hard enough to properly document on projects, as you know, and as I know, doing proper as-built and red lines is for some reason very difficult for folks to do. So this is something that I've seen cause a lot of problems.
We see this fairly consistently as well. We're just not sure what's out there. So moving this to, say, a managed network, and if you're going BACnet IP, a managed network is definitely recommended. So you can tell where things are going. You can get into the system and see what's starting to fail, or you can see what you're connected to in order to properly diagnose and kind of solve that problem.
Okay, so real quick, I'm going to play devil's advocate here. Unmanaged, or that's probably not the proper term. I'm going to play ignorant here. Unmanaged versus managed. What does that mean? And control plane versus the actual data plane. What are all these concepts?
Unmanaged is just connectivity, right? I'm going to plug something in and it works. I don't know where the data goes. I don't really care how it goes. I open up my BMS, I see my controller. It's that simple. When you talk about managed switches, it means I can log into the switch and I can see the data going by. I can see if all of that data is working, if it's routing. I can see if there's errors. I can see if the port's disconnected. Let me bring it back to this. You have a problem. Customer calls you and says, I'm cold. Pretty common, pretty generic. You're going to log into the system and say, well, yeah, box is offline. Okay, great. But now what? That's all you know. You don't know if it's power. You don't know if it's network. You don't know if it's the controller. You don't have any information whatsoever. So now you have to load up your truck with all these different things and hope that you've got it right. Go to site and try and figure it out. If you could at least log in to the network and say, actually, the port's turned off or the switches failed. Okay, well, now I know what to do.
Yep. Yeah, so that's a really big difference because especially when we start to talk about PoE, which we haven't talked about to this point yet, but that is another aspect of that star pattern is power over Ethernet. And so how would that play out, that scenario, if you had a star pattern and you had a controller that was powered over Ethernet?
Well, the power over Ethernet would be fantastic at that point, but it's very expensive in labor to install. However,
true. Yeah.
Your reliability is much, much higher because it only fails in one point. If that room fails, it's only a couple solutions and it doesn't take down anything else around it. This is a great case for not using BACnet MSTP. As we all know, if it fails, depending how it fails, it can do drastic damage on that network.
Yeah. Yeah, very true. I mean, I was kind of joking when I said someone flipping the end of line in the middle of the trunk run, but I've seen that where folks are trying. Some manufacturers, I don't think through the design of their controllers very well. I think some of their engineers have probably never spent any time in the field because they put the end of line right next to a terminal block so that if your screwdriver accidentally bumps that, you turn on the end of line. Which I may or may not have done in the past. A lot of my stories are from personal experience, but that will take down an entire trunk, and it's not something that you're going to scope out. It's weird. I just don't get why, with the benefits I'm starting to see, there's still hesitation, which hopefully the folks in the audience will comment and let us know, because I'd like to deal with that.
Well, you're very right. I mean, let's just dive into MSTP for a moment. MSTP has done a great job so far, and there's a lot of pains and things associated with it, like anything else. But the amount of benefits that it has had is now over. Right? You are every time you go into an MSTP network, you struggle. It's got limitations. It's full of wiring issues, quite a bit of wiring issues. We have another webinar on that all by itself. Going forward, moving into a newer technology, it has to happen. And there's no possible way that we can hang on to MSTP forever, right? And as there's a big pull with the IoT, there's a big pull of everything going to IP. These things are dragging it out, and we're going to keep driving IP, and it's going to mean that MSTP is naturally going to start to diminish and start to go away. So if either way, these guys you're going to go to IP. Either way, it's inevitable and it's going to happen. So the sooner that you understand IP networkings and start moving forward, the more successful we're going to be. And this goes past just understanding MSTP networks. It goes to manufacturers as well, right? If I'm going to build a brand new device, what protocol am I going to choose? May not be MSTP anymore, which was my default choice. I may take my gas sensor and now move it to IP.
Okay. I'm seeing we got some questions coming in here. So we got a question about the network number, how it's used, and how we should be using it. Yeah,
this is a great question. This is from a university. So there's a question here on how is a network number used in BACnet networks. And in BACnet, there is a finite number of addresses, BACnet addresses that you can be used, right? There's only so many out there. So when you start looking at trying to incorporate all these different vendors that exist on your site, what do you do with the BACnet network or the BACnet numbers? What do you do with your instances? How do you deal with that? Because you have to start to logically separate it. Otherwise, you're going to run into a problem with duplicates.
So that's a really good point. And actually, it's funny. While you were talking, I brought up Wireshark, which I highly suggest anyone who's a technical professional go to Wireshark and then go to like Steve Cragg's site and grab his sample Wireshark captures. And if you really want to, yeah, I always butcher the guy's name. Forgive me if you're listening. So the thing is, if you go through a sample PCAP, a sample Wireshark capture, you'll really start to understand, because to your point, a network number is like a subnet, or it's like a VLAN rather. So it's like a VLAN number in that it needs to be unique, and that let's say you have network number 100. And under network number 100, you have all of these device IDs, because a device ID has to be unique because a device is a BACnet object, right? So you've got this device object under the network number. It needs to have unique device IDs, but then you have a different network number and you can reuse the same device IDs under that new network number. So the network number is a way of segmenting devices. Does that make sense?
That makes great sense. Yeah, that's a great way of handling it.
But as you've probably experienced, Ryan, this all comes down to having a BAS standard and having a network standard. This is why, in my opinion, IP is much easier to have a network standard around than a MSTP network. But regardless of what you do, you need to have some form of standard for numbering your networks, numbering your IPs, numbering your your IDs.
Yeah, I think ultimately this opens up another conversation, but it's going, well, now before on an MSTP based network, I really only needed to worry about my network numbers and the topology. Now what we're adding is a little bit more complexity of IP. I need to have a structured and a well-documented IP type design, and I need to have that also with my network numbers in my BACnet.
Correct. Because the network number and the MAC address are added. I'm going back to my memory here. If I remember correctly, it's the MAC address and the IP address that are added together to create the BACnet address, if I remember correctly. And that is specific to a network. But now I'm going down a very deep rabbit hole. So I'm going to stop before I go too far down that.
Why don't we segue here a little bit? We've been promoting IP quite heavily throughout this webinar, but I think what we really should discuss, at least for a few minutes, is what are the reasons to not go IP? What are the bad things about it? Sort of the cons. Or are there any? Yeah, I could say it again. What are the cons for using IP?
Well, one, you have to understand IP and IT networks. Two, you have to design.
There are the design changes. There's new limitations, right? We can't run 4,000 feet. We can run 300 feet. There's a lot of new learning curves. So I think as you're transitioning into your IP journey, then it's great to take some courses, learn a little bit more about IP and how it works. Figure out that I can actually do a little bit more with it. You know, with IP, we can secure it a little bit better. We can do a lot more things. We get more control. IT, I think, is going to be happier overall, rather than putting in some sort of technology that they don't understand. At least in this case, they start to understand it a little bit better. So the conversations that we have with the people that we need to work with to put these in buildings should get a little bit easier, as long as we have the knowledge.
Mm-hmm. Yeah. Yeah, I think another potential thing is just learning, and it's, as you said, knowledge, learning to use different tools, learning to be comfortable speaking with IT folks. That is something that it's not hard to do, but it's just different. Also, you're engaging now another stakeholder during the construction process, which is different. You had control over your serial networks, whereas now you have to have different processes for project management because you have to engage different stakeholders, especially on new construction.
Do you have any advice around that, on how to help some of these guys with that process?
Well, for one, you got to figure out if the IT network's going to be even installed. Because typically the IT network is furnished through a different budget and is put in place after or near the end of the completion of the building. So you've got to go and make sure that you are coordinating that aspect. The second thing is going and making sure that you engage the IT group early so that they're not surprised.
That I would agree with 100%. Always find out what you need to do, if there's any security protocols you need to pass, what needs to happen, how do you get outside access if you need it, all of those sort of things, and make sure that discussion's up front. Because that could make or break your job if the coordination takes too long.
That, or you just build an OT network and bypass IT completely.
You can bypass, or you can still work with them from an OT perspective, but you still want to say, hey, IT, I'm coming in, I'm going to put in my own network, here's what it looks like, we need to tie in here, and this is a level I'm involved in.
Yep.
And just tell them what you're doing. As long as you're open with them, I think they'll be quite happy.
Yeah, in most cases, I agree. Yeah. So I'm just going to correct myself based on a comment around the device IDs. Yeah, the person who said you can't reuse device IDs is correct. I was thinking of object IDs under a device. So like if you have AVs or BVs, you can have an AV1000 and reuse that on multiple devices, but you can't reuse device IDs. That's the thing about memorization of protocols. So.
Well, that brings up a great point. If you are growing your network, say you had individual BMS networks or BACnet networks under each building, and you merge the buildings together, I know for firsthand, every time you start a brand new building, 100, 200, 300, right? Well, now you've got multiple buildings in the same scheme. So that's where, if you have any idea of what the future's connectivity of your buildings are going to be, then you would offset it by a certain amount. And this is very common in school districts, very common in larger campuses. So it's very cost a lot of money to change your networks and bring it over, because that's changing your programming, you're changing your graphics, you're putting in this network, you're doing a lot of things. So a little bit of foresight goes a long way.
Yeah, because it depends on the BAS. Some BASs will cascade changes. Others, you have to manually go and rechange everything. So it just depends. I saw someone brought up the costs, the operational costs of using IP addressing. So the thing is, they say there's a charge per drop. Let's go to the next topology, because a charge per drop on a ring topology is going to be completely different than a star topology.
Oh, absolutely, for sure.
And this is why I felt it was so important for folks to understand the different topologies.
So, should we dive into the ring a little bit? We have a few minutes left.
Yeah. Do we have any more questions, or are we could just dive in?
I think we've answered the couple that have come through so far.
Perfect.
So the ring topology, this is where you're looking for a little bit of redundancy. I mean, some people on site tend to either purposely or accidentally sever the wiring connection, and this would be a case where you bring it back together, especially if you're playing in unions and all that fun stuff. But depending on how much reliability you want in your site, the ring makes perfect sense. I could run out, do a daisy chain, and then tie it right back in to the same switch or a separate switch that's connected in order to maintain that connection.
Yep. Yeah, and now we bring in a couple IT concepts that scare folks at first, but they're really not that scary, which is like broadcast loops and rapid spanning tree protocol and things like that, because you essentially have a loop, and we got to remember about broadcasts. But as you know, because you all are switch manufacturers, most switches that are built for this case have that technology built into it.
That's right. It's already in here. So it's as simple as bringing the connection back and it works. Some things to note, there's always caveats, right? There's a certain amount of time required before it switches over and that sort of thing. But the biggest point is your network's back up and running.
Yep.
Right. And I always like to say it, just like in traffic, you can build your network to take a hit. Don't build it so if you have one little crash, it takes down the entire network.
Exactly. Which is the point of, you've got this topology, then you've got, I don't know if you guys have bus topology on the slide deck, do you?
Yes, we do.
Yep. Daisy chain, yeah. So, I mean, both of these address that IT cost, both physically or in capital cost and operational cost.
And I like that that it calls per port. That's another driver for building your own OT-based network as well. Because if you're going to do a calls per port, then I'll just ask for one connection to IT, and I'll deal with the rest on my own. Right. So that's another way that you can get around that operational cost.
So I was just reading this. This is the fun of taking questions during a webinar. I was reading the questions, but I heard what you said. You're absolutely right about avoiding cost, and this ties in with that daisy chain and ring network is the IT folks being afraid that there is a daisy chain of IP. And I actually dealt with this on one of our students' weekly office hours calls, and we talked through this. And the fear was the IT person said, well, anyone could come in the middle of that chain and pull out an IP device and put in a new IP device. And, he had been trained. So he said, well, yeah, but the MAC address would be unique. And then the IT group goes, well, there could be MAC address spoofing. So, and as we got to talking about this, we said, yeah, but isn't the bigger issue that they're in your ceiling, in your building, or in your mechanical room, and no one's noticed this person in the ceiling or the mechanical room pulling a controller out and putting a new one in?
Security is all about layers, and start with locking the door, right? Once you get into that and work all you're right. I mean, he got in the front door, he got all the way into the mechanical room, he got a ladder, he climbed up the ceiling, and there's a lot of pieces all involved in there. And if by some chance they replace the device and they spoof the MAC address and they put programming in, and you've got a long way down the path. If that's the case, that guy was probably getting in almost no matter what you wanted to do. So there's the more layers you add, the better. And the biggest.
I really want. Oh, go ahead.
Well, the biggest piece is with IP, you can secure it. You've got a chance. With MSTP, forget it. There's no chance. I mean, you just replace it. I'm going to match the dip switch between this one, and it's going to work.
Yeah, there's no management protocol. One more note I want to make on this, because it's a really good analogy that a lot of folks don't think of, is IP is a logical protocol. So logically, that daisy chain is no different than a wireless AP with a bunch of devices connected to it. So if you think about it, right, that switch port that has a daisy chain or a ring coming out of it and connecting all these devices is no different than an AP, an access point, a wireless access point coming out of a switch port and pulling in, a dozen to 100 wireless devices. The only difference is that instead of wireless, there's an IP protocol. There are still access control protocols that you could put in place, because someone could scan and find the SSID of the network. Someone could spoof another device on wireless, yet you don't get the same pushback on wireless, even though it's logically the exact same situation. I really hope that makes sense, because it's important to understand.
Isn't that funny? It's funny how that works.
What's that?
That's funny how that works.
Yeah. I mean, I hope that really clicked with the audience, because a lot of the pushback you'll get from IT, if you understand IT and IP, when you start to think about it, like envision that daisy chain. It is the same thing as a wireless network.
That's right. Everything comes back to a single location.
But they're opposed to the wireless opposed to the wired and not opposed to the wireless. Why? Because they don't understand, most likely.
Right. Or they're not putting it into that context.
Yep.
All right. Well, before we stop and step off here, there's a few resources that all of you can go through, starting with Phil's. Phil's got a lot of resources on his website and a lot of training specifically in this area. There's a few different white papers that Optigo has created that feel free to download and read, distribute, give us your comments. BACnet Institute has quite a bit of information on the BACnet protocol itself and what all the pieces mean. And last, there's a lot under the BTL certification and kind of what that means under BACnet International. That's another great resource of what's up and coming, what they look for. If you don't know, BACnet's trying to move into securing BACnet. As we know, we kind of skipped that topic. Maybe we'll leave that open for another future webinar. April, I've been told. So it's great I mentioned that. And we'll look forward to upcoming webinars. Any additional comments, Phil?
I just want to make sure that everyone understood kind of what we covered, and that if there's any last minute questions, that we get those answered, because, this is something that you and I have spent years learning. So I don't want folks to feel like, oh man, I didn't understand this. I don't know what I'm doing, because I see that from our students. They think because they don't get something that someone like you and I have spent 20 plus years learning, that somehow means that they don't know what they're doing. And I really would hope that folks would just ask.
No, there's a big difference there. Back in the day when I was asking for a single one IP address from IT, it was a huge discussion saying, what do you mean BACnet? What do you mean UDP port? What do you mean? Like all of those type of discussions are starting to go away, and it moves into something else. Thank God. But it's the conversation is getting easier. So yeah, a little bit of knowledge, and IT is going to be a little bit more receptive.
Well, and I will tell folks, if you're in this industry and you don't have IT knowledge, you need to, because there's so many competitors on new bid work that the ability to have margin in your jobs is getting really hard. So you're going to make up that margin gap by having services. And a lot of the services you're going to provide are going to be remote operations, analytics, things like that require IT expertise. And that will enable your business to have higher margin work, which ultimately for the technicians in the audience, that's how you get pay raises. That's how you get promotions. Your company has to profit. As a business owner, I know that, and you're a director of a business unit, so in order to promote people and for people to get pay raises, you have to be profitable. And in order to be profitable, you have to have some expertise on areas that are high profit business.
Well said, Phil. Well said. Well, let's leave it at that. I thank you all for your time. It's been fantastic. Thank you, Phil, for your valuable input as always. Always enjoy having these conversations.
Yeah, me too.
Thank you very much. Feel free to reach out with any questions that you have, and we'll make sure that we answer them to the best of our ability.
Thanks, Todd. You all have a great day.